In this video, I'm going over number 2 through 5 to review permutation, combination, and factorial. So I want to know at one time during the test, can you actually compute a value? Okay, so what you do to compute, so first of all, if it's just a permutation of something, this would mean like an arrangement of, say, 7 things into 4 spots. Okay, so what we do is we draw 4 spots, and then you just start doing 7 factorial till you run out of spots. Okay, so permutation is when order matters. So if I said, how many ways can I put 7 students into 4 seats? Okay, and the order that they sit matters, right? Then I would do this. So this is how we evaluate a permutation. So to do a combination, the numerator, right? We change the P to a C and put it in the numerator. So that means draw 3 blanks and start doing 6 factorial into those 3 blanks, and then divide it by 3 factorial. Okay, so it's always this number at the end, factorial. Okay, which is 3 times 2 times 1, and we should not need our calculator because 3 times 2 is 6, so the 6's divide to 1 and leave us with 20. Okay, so in number 3, when we're talking about groups, okay, so if I had Bob, Bill, and Sue, and they're a group, okay? It doesn't matter how I arrange them if I'm talking about a group, okay? And so other things that are keywords for combinations, a lot of C words. If you're making a choir, right? So it doesn't matter, that's just a grouping, or a committee, or a card hand, right? I play multiple card games, and I've never played one where it mattered the order in which my cards were dealt to me. All right, so a card hand or a team, right? If you're choosing kids to form a kickball team. So those are all when order doesn't matter. So as soon as order doesn't matter, you want a combination. Okay, if order does matter, then you're putting students into different arrangements of seats, like we were up here. Okay, or you've got a school play and there's different roles. So how many ways could you assign students to different roles? Okay, so if I have Bob, Bill, Sue, right, they're all one group, but then if Bob's line leader, Bill is snack helper, Sue is paper passer, right? I would get something different if I said, oh, well, wait, Bob will be snack helper, Bill will be paper passer, Sue will be line leader. That's a different assignment, okay? And I could get another different assignment if I said, Bob will be paper passer, Bill will be line leader, and Sue will be snack helper. Okay, so this would be a permutation, okay, where order would matter. So a word problem for 10 factorial. So remember what 10 factorial means. 10 times 8, 10 times 9 times 8 times 7 times 6, all the way down to ... 1. Okay, so this just means arrange 10 things into 10 spots where the order matters, right? So maybe I have 10 photographs that I decide to hang up on my wall, right? How many different arrangements could I put those 10 photographs in? Okay, or the problem I put on the answer key, there are 10 students in a class, how many ways can I arrange them into 10 seats? Okay, so again, anything where order matters. So that's the difference. Order mattering versus order not mattering, where we just have a grouping.